All right, so good afternoon, and welcome to the panel on generative AI security and privacy. I'll be your moderator. My name is Lorica. I wear many hats. I guess I might as well advertise something. I'm also the chair of a new conference, the AI conference, which you can find at aiconference.com.
Hi, I'm Joey Gonzalez. I'm a faculty at UC Berkeley. I'm a co-director with Raluca of the RISE computing labs and New Sky computing labs. I'm a machine learning guy. I do a lot of work on machine learning systems. A lot of the stuff recently has been around LLMs. My team built Vicuña, one of the big open source models. We've developed the Fast Chat Arena, which has become a great way to evaluate models. We've been developing Gorilla, a great way to use models in a shell and interact with the cloud using LLM technology. We've been developing new ways to do large-scale model serving, VLLM. So a lot of cool stuff in the LLM space, and starting to think maybe a little bit more about the implications on security.
Great. You guys know me already. I'm Raluca. I'm a professor at UC Berkeley, working in security and privacy, and confidential computing is a big part of my work. I'm also co-founder of Opaque. And since my introduction was shorter, I'm just going to brag about two things about the newer guest that you haven't heard about yet. Lorica runs this super interesting podcast on the data exchange. Lots of LLM topics, so take a look. And Joey's Vicuña LLM model is the best open source LLM model right now.
Thanks, Raluca. I'm Phil Rogers. I'm a software architect at NVIDIA. I've been working on data center compute and GPU software stacks for the last 10 years, and the last few years focused on enabling confidential compute on GPUs.
And hi, everyone. I'm Vikas. I'm the head of product for Azure Confidential Computing. I've been at Microsoft for 15 years now, way more than I expected. But I was the first hire, I guess, on Azure Confidential Computing, and we've built the team from scratch, and I've known many of these co-conspirators for a while now. So.
All right, so this is a privacy and security conference, but I think we'll start with setting a baseline for generative AI and LLM. So I guess the first question is, what are the use cases that you're actually seeing? Or are we still mostly just in the let's talk about the phase? And secondarily, what's the common usage pattern? Are people using public APIs? Are they using open source models, custom models? So Joey.
I can start. Yeah, so I guess I should add, I also have a startup, Aqueduct. We've been thinking of taking machine learning to production. And pre-LLMs, that meant for most people, it's like basic machine learning. Post-LLMs, for most people, it's about trying LLMs. So what I've found talking to customers is that LLM technology, generative AI, is something they're very excited to integrate into their workflows. Their leadership is eager to figure out how it will change their business, but they're still trying to work through a lot of the details. And a lot of that means composing different technology stacks. A lot of it means making decisions about, should I call external cloud providers? Should I call OpenAI with my customer data? Should I run an open source LLM that might have some range of commercial licenses? Should I do things that might sit in between? And that's something that I have lots of thoughts on and we can dig into, but that's what I'm seeing today. Certainly in research, we're doing fun stuff, trying to build LLM solutions to various, calling APIs, cloud technology problems.
So mostly still in the kind of exploring and planning.
That's what I'm seeing, yeah.
I would say, from my perspective, I see a lot of use for LLMs on the productivity for coding side. And that's where I see a lot of the confidentiality issues as well, because in order for the LLM to give you good results, you have to upload a prompt that is extremely specific, proprietary, for example, the Samsung case. So that's where I see a lot of the privacy issues as well. Besides that, obviously, the poem for today was from ChatGPT.
So Raluca, you folks demoed something this morning. So do you think that generative AI and LLMs will be the killer app for confidential computing?
That's a good point. Obviously, I cannot predict the future, but I think it is such an incredible opportunity for confidential computing. I think it's like so much energy right now in that space, and it just makes sense to use confidential computing because the more relevant generation would be based on proprietary company data, right? When you can fine-tune on organization data, when you can answer to inference queries on organization queries, right? So I think that there's a tremendous opportunity for confidential computing. It's probably going to be, if I were to guess, one of the killer applications. Yeah.
Yeah, I mean, obviously, generative AI is still in its infancy. And we see a lot of people getting their first experience of it with cloud and with text-to-text and ChatGPT, as we've discussed. One thing to bear in mind is a lot of people's first interaction with LLMs is with foundational models. Or if they have had some supervised fine-tuning, it's also on public data. Where LLMs are, I think, really going to take off commercially is when enterprises can do fine-tuning and reinforcement learning with human feedback in a way where they know that that fine-tuned model is protected and is theirs, right? So even if they've started from an open source model, foundational model, they've modified it and they need an environment in which they can do that securely.
So Phil, what about, are you hearing people explore these retrieval augmented architectures where you have an LLM and then maybe a vector database or a knowledge graph?
Yeah, absolutely. I mean, LLMs are often going to be one stage in a more complex workflow. And also, you know, there's quite a lot of discussion in the community at the moment about, you know, how big are LLMs going to get? Or does it make more sense to have a number of smaller LLMs and either have them compete or work in some kind of workflow? So I think we'll see a lot of heterogeneity in the LLM environments. But of course, all the focus on the moment is
like a mixture of experts. Maybe you have an LLM for legal questions, another one for accounting questions.
Yes, exactly.
Yeah, and I think, you know, I wake up in the morning and I see a bunch of these missed conversations where people around are just asking me, how can I get confidential computing in LLMs going? Like, this is 3-4 times a week at this point. Like, literally, the amount of interest that's going on right now in LLMs is through the roof. And the use cases are exactly, you know, what Phil talked about, right? I think you start with foundational models, but the real fun happens when you can fine tune. The real fun happens when you can do it in a private way where, you know, your interaction with the model, the prompts are confidential, right? There is a whole bunch of use cases that we are seeing. And I think there are two sort of categories of use cases and demand that we see. So in Azure, we're on the front lines. We see this kind of happening constantly, especially with our partnership with OpenAI. I think one is obviously FOMO, you know, fear of missing out. Everyone, doesn't matter if you're a government agency, doesn't matter if you're in healthcare, whatever, like every executive wants to get in. That's clearly one element of it. But I think there is clearly depth, there's a lot of depth behind it. There's a lot of opportunity that us as humanity can now unlock because we are at this stepwise function acceleration in AI, right? And I think now that, you know, the world is going to run out of, you know, data. I don't know who presented this. I forgot the slide. By 2026, I think it was Ian who mentioned this in his talk. Fine-tuning of the data is going to be critical, right? Like, how do you get the AI to say what you want with the data that you have in a private way?
By the way, building on what Raluca said, Stack Overflow actually just had a survey. I think they had 70% of developers are already using some kind of coding assistant. Yeah. And then, in fact, the percentage rises with more experience, right? So the more experienced developers are using it.
Yeah, and building on your comment and also Vikas's, I'm sure many of you played with ChatGPT, right? And you were impressed, wow, this is really good. But that was only using public data, right? So imagine now if ChatGPT were to be, you know, fine-tuned or whatever other LLM fine-tuned on your organization's data, on your code base that you're working on, right? Or maybe your personal lives, how much more useful and impressive and how much more productive it would make you, right? But for that, to be able to have access to that confidential data and private data, it has to be done, like Vikas says, in a private, trustworthy place, like confidential computing.
So I want to clarify something about how these models learn, this kind of mix of fine-tuning and in-context learning. This is something that I will say it's still very much open research, but the sort of common wisdom, I think, today is that fine-tuning is a mechanism to endow behavior in a model. So we do this pre-training on vast amounts of data to try to capture human knowledge into a single language model. And then we use fine-tuning, or at least conceptually, we try to use fine-tuning to make that model not a thing that finishes documents, but a thing that answers questions, that responds or behaves the way a human would behave. And then the, at least, hope today, though this could be wrong, is that to endow a model with knowledge of our organization, to give it context, that we should use what is called in-context learning, stuffing into the prompt the data that's needed to reason about a task. What is neat about this is it does give us an opportunity to segment the problem into parts. What is the relevant information I need to answer a question? Maybe I can use simpler LLMs to pull out just the relevant information from my organization without having to send that data to the cloud. Then maybe I can anonymize that information and put it in a question which I hand to the cloud to a much more sophisticated LLM that takes all of human knowledge and tries to synthesize a coherent answer. This is all open, but I think there's something to think through more as we look at privacy and security, how we mix this balance of retrieval augmented generation, or RAG, and fine-tuning itself.
I did want to mention one other use case that sometimes I think gets overlooked because, with language models, we're looking at tokens and looking at billions of tokens and predicting the next token in a sequence. And most of the attention is on human language because it fits that model very well. But there are other areas like biology and chemistry and genetics where DNA can be expressed as a series of tokens. So we also expect LLMs to become huge in those areas where they're not outputting human text at all, but they're being prompted to generate hundreds of thousands of new drugs and then be able to then run them against diseases to predict best fits, which then, of course, goes to simulation and trials. But I think LLMs are actually going to lead to a lot of breakthroughs in medical drug therapies.
So building on what Phil said, so genetics, that even raises even more privacy questions. So let's turn to privacy. So what are the key elements of the current confidential computing stack that just naturally slides in and maps into LLMs? And which components need to be revisited? So as Joey pointed out, a lot of the infrastructure, for example, for model serving was not designed for these ginormous models, right? So which parts of the confidential computing stack will just work right out of the box?
So first, it's super critical, the fact that you guys at NVIDIA are now shipping very soon the GPU enclaves. I think that's integral to LLM components going inside enclaves. Currently, they can run in CPU enclaves. Rishabh showed the demo. A few other companies have confidential AI. But obviously, with the CPU, it's going to be slow, both prediction and machine learning training. But right now, with the GPU enclaves, that can really speed up. And in fact, I really loved, Phil, your talk where you said that performance is going to be very similar. Compute performance in the GPU enclave will be very similar to regular. So imagine the opportunity of having confidential computing at the usual speeds that you're used to. So I would say any part of it, the model, the prediction, so you can train a model, an LLM model on confidential data. Then you can keep it still in the enclave. You don't have to release it. You can ask queries to the model in the enclave. So those queries are also going to be private because they're going to show up encrypted at this model. You can do the relearning from those queries also in the confidential computing. So you don't worry about who gets to see what gets to see. So in principle, the whole LLM pipeline should be in confidential computing.
Yeah, I agree with that. And I just want to do a follow-up comment on the performance issue. One of the things I said in my talk is the compute will run at full performance, absolutely 100%. We will be limited in cases by the I/O with the encryption back and forth to the CPU. So if you have a lot of I/O, say images running into a small model with just a little bit of compute, you'll see some degradation. The weird thing about LLMs coming along at just this moment is LLMs have a huge amount of compute, massive amount of compute. Sometimes it doesn't even fit in one GPU. Small prompt, small output. And that's why for LLMs in particular, on confidential GPUs, you get extremely good performance.
So Phil, what about, so I think right now we're so obsessed with LLMs, we forget other data modalities, images, and, so you can imagine in the future, you will talk to these systems in a variety of modalities, right?
Yes. And you mean, I assume you mean things like text to image?
Yeah. So
text to
I
video.
can ask a question, hey, here's an image, do something, right? So.
Yeah.
Yeah.
No, that'll work very well too. And of course, it all comes down to the balance between the data in, how much compute there is to do, and then the data out. And typically with these LLMs, the compute is very high. So I'm very optimistic, even when we've got images or video as our I/O.
Confidential cloud.
Yeah, I mean, I think this is sort of the way we need to look at it, like, which is how do you make sure that your entire data pipeline is confidential as well, right? I think we are starting with confidential computing, right? The work, that Phil and NVIDIA is doing, the work that Intel and AMD are doing is setting the fundamental sort of building blocks, the primitives, to allow us to run these LLM models in a private way. But everything is a solution. It's an end-to-end solution. Customers don't look at their data as just being compute, right? So what we are trying to build towards, honestly, as a community, is not just confidential computing, it's a confidential cloud, right? Like where everything that you touch in this generative AI models, the model weights, the inferencing that you're doing, the data that you're touching, the data that comes in and out, the prompts, the front-end servers that are taking the content, everything has to run in a confidential environment. We call that sort of the confidential trust boundary that you have when you're running in a confidential cloud where everything that you're running is confidential and only the code gets access to the data and nobody else.
So Joey, which parts of the MLOps stack are you most concerned about as we use more LLMs?
Yeah, so I want to jump back briefly to the question of kind of where is the state of technology for confidential computing for LLMs, for example. Having an enclave is really important, but if you say, let's say my lab, and we take all the conversations on Slack and you adopt this philosophy of fine tuning, and I start feeding those in to make the LLM really understand me and my lab. And then some student comes along that engages the LLM in some conversation, it starts spitting out a conversation I had with another student. That's a problem. Yeah. And so as maybe within a trust zone or trust community, I've built a fine-tuned model, it's still not enough. And you start to want to have access to knowledge or what knowledge is exposed by that model. And we don't have the primitives to do that through fine-tuning. Through retrieval augmented methods, we can partly do that, but we don't have the advantages perhaps of fine-tuning. So I think they're open questions. And the situation's a little worse than I think you realize. So at the size of these models, hundreds of gigabytes, paging a separate model in for every single user's conversation is impractical. Even right now, as we're running these big arenas, we have trouble without enclaves supporting multiple models on the same piece of hardware. And if that piece of hardware is getting queried once an hour, it's not economically sound to do that. So finding ways to mix different workloads on the same piece of model is important to get good hardware utilization. If we imagine a separate fine-tuned model for every segment of an organization, they're going to sell a lot of chips. Yeah.
I really like your comment a lot about a student asking something to the LLM model, the LLM model spitting a conversation between Joey and another student, speaking even maybe about the original student. And so indeed, I mean, confidential computing by itself would not address that problem, but in conjunction with technologies like differential privacy, that can really, can work differential privacy inside the training, when you do the enclave training. That's going to ensure that the model does not answer queries too specific to any one user or any one conversation. And the other thing you could do, and I think this requires a bit more research, and we're working on it, is it's very clear when you look at Slack conversations who is supposed to see it and who not, right? Users involved in the conversation, in the Slack channel, they should see it, nobody else should, right? So there's access control there. So now teaching these LLMs to respect access control in some form. That's, I think, a very interesting line of work.
Yeah, I can imagine taking this a step further. You think of these big LLMs run by Microsoft in the cloud being general knowledge LLMs, perhaps using enclaves, not fine-tuned, but then maybe more fine-tuned conversation, smaller LLMs for dealing with my conversations with students. And then giving them some notion of what information can be accessed when doing this retrieval augmented generation to give some gradation of control over what knowledge they have, while also retaining the power of these large LLMs to reason about these complex tasks.
So Phil, taking the lessons learned from computer vision, right? So they started out with big models, then they learned compression, distillation, quantization. They started putting their models on doorbells, on phones. So there's got to be a time where we will have some of these LLMs offline on the edge, on devices, right? So what do we do about privacy then?
Well, you're right. We do see this this desire immediately to reduce, right? We've seen people taking these open source large language models and not satisfied to run it on a data center GPU, find a way to compress it, reshape it, anything to get it onto a workstation GPU, so that then people can work on their laptops and workstations. Things will migrate to the edge, and I do see confidential computing going to the edge, right? There's nothing about hardware enclaves that says data center. We build root of trust and a lot of security and separation into the SoCs we build at NVIDIA for automotive and Jetson, and we absolutely will add in confidential computing into that product line over time.
And I think
Confidential edge.
Yeah, I think let me add on to that, because when we talk about confidential computing, obviously we start with the cloud. This is where it started, but we totally see confidential computing as being very, very relevant on the edge. There are just some scenarios that don't permit the data to go to the cloud.
And
Some
physical attacks and
physical attacks, regulations, just the size of the data, right? So what we are really looking for is end-to-end confidentiality, right? Whether that's on the cloud, whether that's on the edge, there might be scenarios where a model needs to go work on the edge. The model developer wants to make sure that their AI model weights are not being stolen away, right? Like the model weights are the IP, right? So confidential computing on the edge, along with the cloud, allows us to have that completely end-to-end. I mean, cloud doesn't honestly need to be involved as well. You could do this all on the edge. The element about protecting user privacy, ensuring that confidential computing gives the assurance that there is complete end-to-end protection, along with the enclave that Raluca kind of talked about, that is really the future that we're all kind of getting towards.
I really agree with Vikas, because when you think of computing on the edge and on-premise, it doesn't just have to be an open source LLM. You can actually have a proprietary LLM that's completely confidential running on-prem in your organization. Why? Because confidential computing can protect that model, can protect the LLM provider from their model being revealed. And basically, then you can even run proprietary models that may have better accuracy and better performance than an open source one.
Yeah, for example, just to kind of add on to this, like when I was at RSA, in April, about 5 blocks from here, I spoke to a government from EU, cybersecurity, CISO, pointy hats. I mean, they were like, of course we want to do LLMs. We have to. We must. National security. But there is no way we're going to allow anyone fine-tune our data. Right, like there's national security data, and here the stakes are high, right? So the confidential computing is the only answer. I would posit in some ways, right? Like I don't know what else is the answer here.
Yeah.
So I think we're out of time. I mean, I can keep going, but
I think we could all keep going.
Yeah, we can wrap it up.
This is a group.
so you have an announcement?
Yeah, I'll make some announcements. We can thank everybody meanwhile, and then I'll go there and make an announcement.
Okay.
Thank you.